Hello friends, today's topic is celestial navigation. Okay, so celestial navigation is a very big part. So I'll be converting these videos into 2 or 3 different parts. Okay, so let's make this as part 1. Okay, so in this video I intended to explain few things like what is celestial sphere, and second thing is what is celestial pole, and the third thing is what is equinoctial, and the fourth thing is what is declination circle, and the fifth thing is what is a celestial meridian, and the sixth is what is declination, and the seventh is hour angle, eighth is prime meridian, and 9 is Greenwich hour angle or GHA, and 10th topic is LHA. Okay, so let's discuss what is a celestial sphere. Okay, so let's imagine okay, this is you. This is you. Okay, okay, you are standing on the surface of the earth. Okay, so let's imagine there is a electric bulb, okay, which is placed under you. Okay, so and it is illuminated, and you are standing on a transparent glass. Okay, if I illuminate a bulb under you, so on the roof, okay, the light will be coming and your image appear like a shadow, right? Image of you will be appearing on the roof. Okay, so consider this concept. Okay, now we are expanding this image concept and lights concept to a bigger scale. Okay, so you are here, this is our earth. Okay, this light bulb is now look very powerful light right now located at the center of the earth. Okay, now if I am going to switch on this light, what will happen? A bright light will be coming and it is illuminated over the space or atmosphere or the sky. Okay, so in the sky we have all our sun. Okay, we have sun. Okay, we have our stars like this. Okay, we have our small planets. Okay, a different constellation of stars. Okay, and we have our moon and some shooting meteors and all those things. Okay, so when you switch on this light, okay, so all the object on the earth's surface will be projected on the space. Okay, so you are here and your image is some projected on the space like this. Okay, if you are standing somewhere over here like this, okay, you will be projected on the outer space like this. Okay, similarly if there is a building like this, and it will be projected on the space like this. So since the space is a vast area and volume, there is no limit, or you cannot say uh, your projection will be so many kilometers from the earth. You cannot say that. Okay, so we have to assume that your image is projected somewhere in the space. Okay, and if you consider if you join all the projections, okay, all the projections like this, if you may consider all the projection, it will be like a sphere similar to our earth. Okay, so in this sphere, okay, all the celestial objects like stars, planet, okay, moon, sun, everything will be included. Okay, so that projection of earth projection of earth on the space, okay, this sphere is imaginary, right? Because actually there is no sphere, so this is an imaginary sphere. Okay, so the radius of this sphere from the uh, is also unknown, because the entire outer space universe you cannot measure. Okay, so this sphere's radius is also unknown, so it is an infinite sphere, okay, with radius unknown. Okay, so with but one thing is common with the earth and this sphere is the center of the earth and the center of the sphere is at okay, both are same. Okay, so the center of the sphere is considered as the center of the earth. Okay, so in this sphere all the sun, moon, star, everybody, all the objects are considered occupies. Okay, so this sphere is called celestial sphere. Okay, so the actual definition is, okay, actual definition of a celestial sphere is it is an imaginary sphere. Okay, so that is true because there is no actual sphere on the space. Okay, so imaginary sphere, okay, around the earth. Okay, so this is our earth and it is around the earth, right? Around the earth. Okay, so the radius everything is unknown, so it is an infinite radius. Okay, and its center, the center of the sphere is common as the center of the earth, so having its center as the center of the earth. Okay, so in this sphere, what we saw, all the celestial bodies, okay, including sun, moon, all the planets are projected, and it is like all these objects are lying on this sphere. Okay, so all the celestial bodies, including the sun and moon, are projected to lie on this sphere. Okay, so this is the explanation and definition of the celestial sphere. Okay, I hope you guys understood what is celestial sphere. Okay, now next topic. Okay, what is our next topic? Celestial poles. Okay, Okay, so like I already told, celestial sphere is a projection of Earth, right? So this is our Earth. Okay, this is the north pole of the Earth and south pole of the Earth. Okay, so when we project the Earth on the space, so we have a celestial sphere, right? Okay, so Earth has north pole and south pole, and this axis is an axis. Okay, if we project this axis towards the outer space, okay, and it will touches the celestial sphere, correct? Okay, so the point where the Earth's axis meet the celestial sphere we can call as celestial pole. Okay, okay, so the north pole of the Earth, where the if the axis meets the celestial sphere equivalent to north pole of the Earth, then it will be called as north celestial pole or NCP. Okay, similarly the south pole, south celestial pole or SCP. So the definition will be, what is celestial pole? Okay, so definition is 2 points. Okay, these 2 points, 2 points where the axis, Earth's axis, okay, axis of the Earth, okay, when projected, okay, and when projected, okay, meets the celestial sphere. This is the celestial, so it is meeting here. Okay, meets the celestial sphere. Okay, so one of them will be north celestial pole, another one will be south celestial sphere. So the definition of celestial pole is this: 2 points where the axis of the Earth when projected meets the celestial sphere. Okay, so next topic we are going to discuss is equinoctial. Okay, equinoctial, CTIAL. Okay, so this is our Earth, north pole, south pole. Okay, and this is our equator. Okay, okay, so when we this is equator. Okay, when we project the Earth on the celestial sphere, okay, sphere, we have north celestial pole, south celestial pole. Okay, so in this celestial sphere we are projecting the equator of the Earth. Okay, so the equator will be projected like this. Okay, so this projection of the equator, okay, and which will be, that is called, this projection of equator, Earth's equator on the celestial sphere, is called equinoctial. Okay, so we have our north celestial pole, okay, and south celestial pole and equator, okay. So the equinoctial. So the one thing is like our Earth's equator is perpendicular to north and south pole, axis of the Earth, right? So similarly, the plane of the equinoctial, okay, that is perpendicular to the celestial pole or the axis, celestial axis, okay. So by definition, okay, what is an equinoctial? Okay, it is a great circle. What is a great circle? The plane of the circle will pass through the center of the earth, right? So equinoctial is a great circle, on the celestial sphere, right? This is our celestial sphere, okay. Okay, so whose plane, right? The plane of this great circle or great circle is perpendicular to the axis of the earth or the line joining the celestial sphere. The line joining celestial sphere is the pink color or the axis of the earth. So with this plane has to be perpendicular to the axis of the earth, okay. Celestial sphere and whose plane is perpendicular to the axis of the earth, okay, earth's axis or the line joining the celestial sphere, okay, or the line joining the celestial poles, okay. So this is our equinoctial, okay. So now the another thing is declination circle, okay. So I will explain declination circle also in the same diagram, okay. So we know equinoctial is a great circle, right? So there is another circle called small circle, okay. So what is small circle? Any circle which is not, the plane of that is not passing through the center, that is a small circle, okay. So what is declination? Declination is a small circle. Why it is small circle? The plane of which is not passing through the center of the earth, okay. So declination is a small circle projected on the celestial sphere, correct. So this is our celestial sphere and this is a small circle, okay. So this small circle is parallel to the equinoctial, okay. So in other words, our earth has equator and latitudes, right? So the same projection of the latitudes is called declination, okay. So by definition, what is declination? Okay, so definition is small circle, okay. It is a small circle on the celestial sphere, okay, whose plane is parallel to the equinoctial, okay. Equinoctial, okay. So basically in simple terms, Earth has latitudes, celestial sphere has declination. Okay, this is the simple explanation, and this is the uh, definition of the declination. Okay, so now let's discuss what is celestial meridian. I can draw the celestial meridian, but I cannot write everything. So let's okay. So what is a celestial meridian? Okay. Okay, what is a celestial meridian? So this is our north celestial pole, and this is our south celestial pole. Okay, the line joining the north and south celestial pole is called celestial meridian. Okay, so these lines, okay, similar, the earth has longitude. The projection of the longitude on the celestial sphere is called celestial meridian. Okay, so this celestial meridian is a half semicircle, half great circle. Okay, why it is a great circle? Because this also has a plane. Okay, that is passing through the center of the earth. Why it is half? Because the line joining north pole and south pole is it start from north pole and ends at the south pole, so it is not completing one circle. Okay, like the equinoctial, that is why it is a half great circle. Okay, so the definition is half great or semi great circle on the celestial sphere. Okay, the plane of which passes through the center of the earth. Okay, passes through the center of the earth and the celestial pole and all those things. Okay, and let's write a proper definition here. Okay, celestial sphere I can remove, because you know what is celestial sphere. Okay, so what is a celestial meridian? Okay, semi great circle. Okay, on celestial sphere. Okay, whose plane, this is a semi great circle, whose plane passes through, okay, center of the earth. Okay, and this plane is passing through the north celestial pole and the south celestial pole, right? So passes through celestial poles. Okay, since it is already written great circle, that means it is passing through the center, right? But there we can draw many semi great circles, right? We can draw many semicircles, but does this semicircles pass through the north celestial or south celestial pole? No. Okay, so if it has to be a meridian, that semicircle, semi great circle has to pass through the celestial pole. That's why I written celestial pole here. Okay, and important thing, the longitude, the Earth's longitudes, okay, is perpendicular to the equator, right? So similarly, the celestial meridian also has to be perpendicular to the equinoctial. This is our equinoctial, this is celestial meridian. So it must be perpendicular 90 degree, okay, 90 degree to the equinoctial, okay, and for all the declination circles, okay, the longitude on earth is perpendicular to equator and latitudes, right? Similarly, this celestial meridian must be perpendicular to the equinoctial and all the declination, okay. So and is perpendicular to equinoctial and declination circles, okay. So this is our celestial meridian. So in this page we covered equinoctial, declination and celestial meridian, okay. So the next topic we will discuss, let's say what is that, that is declination, okay. So declination, okay. So similarly, like longitude and latitudes, or latitude and longitude on the Earth's surface, in the celestial sphere, we use the terms declination. Okay, so let's see what is declination. Okay, this is our Earth. This is the celestial sphere. Okay, and this is our equinoctial. Okay, this is our north celestial pole, south celestial pole. Okay, so this is our celestial meridians. Okay, so this declination. So let's for a easy understanding, what is latitude? Latitude of Earth. Okay. So what is latitude of the Earth? This is the center of the Earth. If this is the equator, latitudes are lines parallel to the equator. Okay, going up and down. Okay. So in other words, this is the longitude, and for example, if we say 10 degree latitude, we can say this is the arc of the longitude, okay, from the center of the Earth. Okay, similarly, okay, declination is the arc, okay, arc on the celestial meridian. Okay, so or an angle. For example, there is another one declination circle above the equinoctial. Okay, so how do we measure what is the value of this declination circle? So from the center of the Earth, okay, from the equinoctial, if you draw a line between equinoctial and this declination circle, there is an angle formed. Okay, so either you can call it by declination is this angle, or there is an arc created, arc in the celestial meridian. This is celestial meridian. Okay, so there is an arc in the celestial meridian. Okay, created between the equinoctial and the declination circle. Okay, so this arc is called declination or this angle. Okay, so in for explanation purpose, the actual explanation of a declination we can write it as, okay, it is arc, okay, of a celestial meridian. This is a meridian, right? Arc of a celestial meridian. Okay, okay, or angle, okay, angle at the center of the celestial sphere. Earlier I said that the center of Earth and celestial sphere are same. Okay, so and okay, so this when we say an angle or arc, okay, so it involves two lines or two characters. So if we say an angle, this angle is between which and which, that we have to specifically say, otherwise this sentence is not complete. Okay, so it is an arc on a celestial meridian or an angle at the center of the sphere. Okay, between the equinoctial, okay, this equinoctial and this declination circle. Okay, okay, so from this means this is the celestial meridian. The arc measured on the celestial meridian between the equinoctial and declination circle. Okay, or the angle at the center of the celestial sphere measured between the equinoctial or declination circle. Okay, okay, so this declination circle, why this declination circle is so important? Okay, so this declination circle, we previously discussed in the celestial sphere lots of celestial objects are there. Okay, so there are many celestial declination circles on the celestial sphere. So one of the declination circle is passing through the any of the this celestial object. Okay, so the position of the celestial object, okay, to identify this celestial object, we will use the celestial meridian and the declination circle. Okay, so when we write the definition, okay, arc of a celestial meridian or angle at the center of the celestial sphere between the equinoctial and the declination circle. Declination circle, which declination circle? That also you have to mention. Declination circle passing through a celestial body. Okay, so for example, if there is a celestial body and the declination circle is passing through that celestial body, then the declination of this star will be the arc of the meridian between the equinoctial and the declination circle or the angle. Okay, so that is what the declination. Okay, so like latitudes we name north and south, declination is also named north or south. Okay, so if at the equinoctial it is 0, if towards the north celestial pole, declination is marked as north, and towards the south celestial pole, the declination is marked as south. Okay, so at the equinoctial the declination value will be 0. As we go higher, the declination value will be increasing to maximum of 90 degree. Okay, so this is the definition of declination. Okay, so the next thing is hour angle. Okay, let's hour angle. Okay, so again I will draw the celestial sphere here. Okay, this is north celestial pole or south and south celestial pole. Okay, so we have the equinoctial here. Okay, and this is the celestial meridian. Okay, celestial meridians like this, going towards the celestial poles like this. Okay, so this is the center of we have earth here. Let's don't draw the earth here. This is the center of the celestial sphere. Okay, this is the center. Okay, now what is an hour angle? Okay, so this is an equinoctial, right? The pink color. So the arc of the equinoctial, okay, or angle at the center of the equinoctial. Okay, okay. Sorry, my mistake. Okay, it is the arc of the equinoctial, right? So arc of the equinoctial or angle at the celestial pole. Okay, okay. So between two celestial meridians. Okay, so when this is basically in our common terms we can say as d long, difference in longitude. Okay, so when two celestial meridians are the difference between two celestial meridians are expressed in the form of arc or the angle at the poles. Okay, so that term is called as hour angle. Okay, so how we write in a proper definition? Okay, hour angle is the arc of the equinoctial. Okay, so this is pink color is our equinoctial. So to measure the hour angle, either you should measure the angle between these two celestial meridians, okay, at the pole, or the arc of the equinoctial. Okay, so it is the arc of the equinoctial or angle at the celestial pole. Okay, contained between any two celestial meridian. Okay, any two. So if between these two or these two, okay, this arc is called or this angle is called hour angle. Any two celestial okay, so that is the hour angle. Okay, now in our first what we wrote, what is our next topic after hour angle? Prime meridians. Okay, next one is prime meridian. Okay, so what is prime meridian? So we know at Earth there is a place called Greenwich, and the longitude passing through that place is called Greenwich Meridian, right? Okay, so that meridian is considered as 0 degree longitude, right? So anything right side of that one is called east, and the left side is west, correct? So when we project our Earth into celestial sphere, okay, so this Greenwich meridian is also projected, okay. So that projection of Greenwich meridian on the celestial sphere is known as prime meridian, okay. Okay, so this 0 degrees, okay. This meridian, which is the projection of Greenwich, is called Greenwich meridian or prime meridian, okay. So Greenwich prime meridian project on a celestial sphere is called prime meridian, okay. So there is one more thing comes when we the prime meridian, Greenwich hour angle or angle or GHA, okay. So earlier we discussed hour angle, that is angle at the celestial pole between the between the two celestial meridians, okay. So let's assume we have a celestial body on the celestial sphere, okay. This is our prime meridian or Greenwich meridian, okay. So there is an meridian passing through the celestial body, okay. Let's highlight with another color, okay. So this is a celestial body, and one meridian is also passing through the celestial body, okay. This is meridian through celestial body, okay. So the difference or the angle or the arc, okay. So the angle between the Greenwich meridian and the celestial body, the meridian passing through the celestial body, is measured, okay, in a clockwise direction like this, okay. So that angle is called GHA or Greenwich hour angle, okay. So it can be defined as Greenwich hour angle is the arc Greenwich hour angle. Now we are writing Greenwich hour angle is arc of the equinoctial, okay. So this is equinoctial. So that arc is between the Greenwich meridian and the the meridian passing through the celestial body, okay. So arc of the meridian passing arc of the equinoctial, this equinoctial, okay. arc of the equinoctial or angle at the celestial pole. Okay, this is the celestial pole. So this angle between these two meridians, okay, contained between the celestial meridian of Greenwich, okay, Greenwich and the celestial meridian. Okay, this is Greenwich meridian of a body. So this is the celestial meridian of the body and this is the Greenwich meridian. Okay, that it is the angle at the pole between the Greenwich meridian and the celestial meridian of the body. Okay, or the arc of the equinoctial. That is what I have written here. Okay, and measured. This is measured in clockwise direction. Okay, so in clockwise direction means normally called as westerly. Okay, or westward. Okay, so in a clockwise direction or westerly. So when we say clockwise, then it is better we say measured westerly. Okay, so the angle, this GHA angle starts from 0 degree to 360 degrees. Okay, if I have a celestial object here, I don't for finding the GHA, I don't measure in anti-clockwise direction. I will measure in this clockwise direction only. So due to that, the GHA value will be more than 180, and sometimes it will come to more than 180 or 270 or near to 360, something like that. Okay, so the GHA is measured westerly between 0 degree to 360 degree. So measured in a westerly direction between 0 to 360 degree. Okay, that is called Greenwich hour angle or GHA. Okay, now there is one more thing called LHA, local hour angle or LHA. Okay, so let me erase unnecessary things. Okay, so in this LHA, it is similar to the measurement thing. Is all the wordings will be similar. Only difference is in the GHA we start measuring from the Greenwich Greenwich meridian, right? So in this case, LHA with the measurement we take from the observer's meridian. What is observer meridian? If you are standing somewhere on the earth, you also have one meridian passing through you, right? So that meridian is called observer's meridian. Okay, so this is our Greenwich meridian or 0 degree lat. Okay, so this is a celestial object. Okay, and you are an observer. Okay, you are standing here like this. Okay, and this is our equinoctial. Okay, and this is the meridian passing through you. You are the observer, right? So the projection of observer on the celestial sphere is also known as zenith. Okay, so I will explain zenith in another video. Okay, so this projection, we have observers meridian. Okay, so and we have another meridian which is passing through the celestial body. Okay, so the angle between these two meridian, the observer meridian and celestial body meridian. Okay, this thing measured in a clockwise direction starting from the observer meridian. Okay, that is called LHA. Okay, so it can be either stated as the angle at the celestial pole between the observer's meridian and the meridian passing through the celestial body measured westwards, or the angle or the arc at the equinoctial. Okay, so this is LHA. Okay, LHA is also the short form of local hour angle. Okay, so the definition is, sorry, definition will be LHA is angle at pole, okay, for arc of equinoctial, okay, measured westerly, okay, from this observer meridian. Okay, and meridian passing through celestial body. Okay, so this is LHA or local hour angle. Okay, so guys, I think I have covered all the topics which I mentioned in the first page. Okay, so this video is almost 1 hour. Okay, if I will normally explain in a small slow speed, then only even if I watch after some time, if I watch, I will understand. So sorry if the video is lengthy. Okay, I am making another part of this video explaining some more terms of the spherical astronomy. Okay, and spherical navigation and or celestial navigation. Okay, so thank you friends.